Okay, so what we're going to do right now, I'm going to take my mask off because I'm 6 feet away from you and so you can hear me better videoing. We're going to go over this piecewise practice that is posted on Google Classroom. We're going to take a piece of graph paper, we're going to split it in half horizontally, and we're going to graph this what we call piecewise function. Okay, this piecewise function is 3 lines. It's pieces of 3 lines. Line number 1, it's this x plus 3. Line number 2 is this 5, and line number 3 is 1/2 x minus 3. It's very important that we see where the domain of this is all real numbers. This is where the pieces break up. This part right here is where the pieces of the lines break up. So the first thing we're going to do, the easiest way to do these particular piecewise functions, is we're going to see where they break up at, and we're going to take it -2, and we're going to sketch, make sure that you have an XY coordinate grid on your, make an XY coordinate grid on your piece of graph paper, on your half a piece of graph paper. I will pause the video as you make your XY coordinate axes. Okay, so now that you have your graph paper, you have an XY axis on your graph paper, we're going to begin graphing this piecewise function. Here's what we're going to do. We're going to take at x equals -2, at x equals -2, we are going to sketch a vertical line at x equals -2. So I have a nice option on my Surface Pro here that I can make a vertical line. Maybe I can. And I'm going to make a, yeah. So I'm going to make a vertical line at x equals -2. And I'm going to make a vertical line at x equals 1. And I'm going to mark those vertical lines. This guy here is x equals -2. This guy here is x equals 1. And the reason why I chose a -2 and 1, it's because of these values right here. This is where the pieces of the function are broke up at, -2 and 1. That's where those vertical lines at. What you need to understand is the graph cannot cross the vertical lines. So now I'm going to look at the first piece. And the first piece is going to happen when x is less than -2. And when x is less than -2, I'm talking about this portion of the grid. And what am I going to do? I'm going to graph this easy line, x plus 3. If I were to use Stickman to graph that, I would go to 3 and go up 1 over 1. But I can't go to my y-intercept. I have to take points over here. So what I'm simply going to do is I'm going to put -2. I'm going to find this function, and I'm going to write this somewhere. I'm going to evaluate this function at f of -2. And I have to see when x is less than or equal to -2, it's this top piece. So I'm going to put -2 into this top piece. This is going to be -2 plus 3. -2 plus 3 is 1. So at -2, this graph is going to be 1. So I'm going to plot that point right there, -2, 1. Now I want another piece, another x value less than -2. Let's just get crazy and go -4. And so I want to find f of -4. Is -4 less than -2? Yes, it is. So if I'm going to put -4 into this top piece, this is going to be -4 plus 3. -4 plus 3 is -1. And so that gives me the point -4, -1. And now I'm going to graph that line over here. That line is this line right here. Y is equal to x plus 3. But I only graph the line when x is less than negative 2. Okay? Now I'm going to graph the middle piece of the piecewise function. Mr. Colson, what is the middle piece of the piecewise function? I have the top, middle, and bottom. What's the middle piece? 5, correct? The middle piece is 5. So now I'm going to graph y equals 5. What is y equals 5? That's a constant function, and I'm going to graph that one in red. That's up here. But if you notice, and here's what's a little bit tricky about this, at negative 2, it's not equal to 5, it's just a little bit above negative 2. So at that point, I put an open circle there. But when x is less than or equal to 1, it is 5, so I put a closed circle there. And what is this piece? This piece right here is y equal to 5. Okay? Now I'm going to graph the last piece. And the last piece happens when x is greater than 1. Where is x greater than 1? X is greater than 1 over here. What am I going to do? I'm going to find a couple points on that, a couple nice points on that. So I want a point greater than 1. Let's get crazy and put in 2. So we're going to find f of 2. And what is f of 2? 2, first of all, is greater than 1, and so I'm going to use this piece right here. And if I put 2 in, it's going to be 1/2 times 2 minus 3. Well, what is 1/2 times 2 is 1. 1 minus 3 is negative 2. So this is the point 2, negative 2. So I'm going to go down here and plot the point 2, negative 2. Okay? Hey, what does the slope tell me to do? I have 1 point. Now the slope tells me of that piece, tells me to do what? Billy? Yeah. What? Yes, you're correct, Billy. The slope says to go from that point up 1 over 2. Up 1, up 1, And now I'm going to sketch that line, but guess what I have to do? Up 1 over 2. I have to take that line all the way to 1, but I'm going to put an open circle because it's not equal to 1. So that's the graph of this piecewise function. Why is it called a piecewise function? Because that function is broken up into what? Pieces. That's pieces. And I have actually found. Now I'm going to get crazy, and I'm going to ask you to evaluate some function values. This is nice with the Surface Pro because it's color coordinated. But now I'm going to continue here. I'm going to say, hey, Billy, can you tell me, Billy, what f of 0 is? What I have to do is I have to figure out where 0 is. Is 0 here, here, or here? 0 is here, right? So if I put 0 into that middle piece, what am I going to get? 5. Because between negative 2 and 1, the function is always 5. So that was an easy one. So let's do another one. Let's figure out, hey, Billy, let's figure out what f of, let's get crazy, -6 is. What's f of -6? Where is -6 at? Mr. Ayler, is it the top piece, the middle piece, or the bottom piece? -6. X -6. Top. So I'm going to use the top rule. This is like one of those function machines that has 3 different rules in it. So I'm going to put -6 in this top piece. So this is going to be -6 plus 3. What is that? -3. And look at that, homeboys. Right there, that point is. -6, -3. Okay? Let's do one more example here. Hey, let's get wild, Billy, and let's find f of 4. Emerson, where is 4? Where is the x4 at? Is it the top piece, the middle piece, or the bottom piece? The bottom piece. So I'm going to put 4 into this. So this is going to be 1/2 times 4 minus 3. Oh, 1/2 times 4 is 2. 2 minus 3 is all -1. And that's that point right there for -1. Okay? Shall we do another example? So now we're going to do example 2. Let's switch to example 2, please. And example 2 is another piecewise function. And I want to graph this piecewise function. Take and create a grid on the lower half of your graph paper, please. I will pause the video as you make your coordinate x. So here we go. Step number 1 of graphing piecewise functions. What are you going to do? Do you know, Billy? Get on it, Billy! Oh, don't. Somebody might watch this, a mom and dad, and they might think that I'm actually yelling at Billy. But Billy is a fictional character. Sometimes Billy is very attentive, and other times he's not. What's the first thing that you do? No, you're right, Billy. You're going to write you're going to create 2 vertical dotted lines. Where is the first dotted line going to be at, Billy? You're correct, at x equals -1, because the domain of this pieces is broken up at -1 and 1. So I want a vertical line at -1. Yeah. And there's my vertical line. And yes, you don't have this fancy line tool, so what I would suggest is I would just pencil in a nice whatever color you want, and I want another vertical line at 1. And let's label our lines. This is x equals -1 and x equals 1. I will be honest with you, ladies and gentlemen, I never understood why this was such a complicated topic, but I will tell you that it is a complicated topic for Algebra 2 students. Okay? I don't know why. Maybe you can help me understand why. Okay. The first piece I'm going to graph is when x is less than or equal to -1. So I ask myself, where is x less than -1? Well, x is less than -1 over here. So what graph am I going to put? I'm going to create this line right here, -x plus 3. I can't use the y-intercept, so what I'm going to do is I'm going to find a couple points. I know it's a line, and what can you tell me about this piece, -x plus 3? What can you tell me about that piece of the graph? Pardon me? The slope is going to be negative, so this line is going to go downhill. So let's find 2 points on that line. Let's find f of, hey, let's get wild and find f of -1 because I can. So f of negative 1 is going to be negative negative 1 plus 3. That's going to be 4. So I'm going to put a closed circle here because it is actually equal to negative 1. I'm going to find one more point. Let's go let's get wild and go f of negative 3. What's f of negative 3? Negative 3 is in this piece right here. So I'm going to put negative 3 in that piece. It's going to be negative 3 plus 3. That's going to be 6. So it's going to be negative 3, 6. And that's going to be about up here. And if I connect those dots, you see that my line is negative. Okay. Now I'm going to graph the middle piece, which is the world's most famous line. And we're going to label that line piece right there as y is equal to negative x plus 3. Now I'm going to graph the middle piece. So now I'm going to graph the middle piece. And the middle piece is y equals to x. Oh my goodness. Can anyone tell me about what y equal x would look like? Because the middle piece, folks, is simply going to be y equals x. That's the world's most famous line. It has a y-intercept of 0, and it goes up 1 over 1. So let's graph that line in blue. That line simply is going to be right there. And that piece is y is equal to x. And there's an open circle here because it's not equal to negative 1. It's when x is just a little bit greater than negative 1. And when but it is when less than or equal to 1. So I am going to put 1 in there. And if I put 1 in and I get 1, this point is 1, 1. So I have this green piece, I have this blue piece. I think this might be in the way. Now I'm going to graph the last piece if x is greater than 5. Pardon me, if x is greater than 1. If x is greater than 1, what does that graph look like? It looks like that constant function, correct? And let's do this guy in black. And it's going to be an open circle. And that's the graph of the piecewise function. In this portion right here, simply y is equal to 5. 3 pieces, 3 graphs. Sometimes the pieces will be connected, sometimes they won't. Now what we're going to do is we're going to find a couple function values. Okay, here we go. Let's figure out what f of 1/2 is. I need to figure out where is 1/2 at. Is 1/2 in the top piece, middle piece, or bottom piece? Elena? It's in the what, dear? It's in the middle. So if I put 1/2 into x, that's simply equal to 1/2. Oh, and right there it is. There's that point, 1/2, 1/2. Let's find this piece. What do you think this piece is, Mr. Yancey? F of negative 3. What piece are you going to use? Top piece, middle piece, bottom piece. You have to find out where is negative 3. Here, here, or here. Is negative 3 less than negative 1, between negative 1 and 1, or greater than 1? The top. So that's going to be negative. Oh, hello, neighbor. I already found it. I already found that. I kind of tricked you, didn't I? That's equal to 6. I'll ask someone here, Billy, what is this guy right here? F of 900 or 9,375. Well, that's not on the graph, is it? But tell me, where is 9,375 at? Is it less than negative 1, between negative 1 and 1, or greater than 1? So what is the function value at 9,375? 5. Okay. Now we're going to do it. We're going to jump ahead to example 5 because it's a little bit harder. Okay. What I'd like for you to do now is to take the other side of the graph paper or a new piece of graph paper, split it in half horizontally, make a coordinate grid. I will pause the video as you do this. So now we're going to do number 5. And I'm going to ask Billy again, what's the first step in graphing this piecewise function? Billy? Billy? Do you know Billy? I do a vertical line, a vertical dotted line at -3. Let's do it this time in green. I'm going to go to -3 and do a vertical line, and I'm just going to sketch it in and not use my awesome line tool. And I'm going to do a vertical line. Miss Billy? Where's the other vertical line going, Miss Billy? At 0. Thank you, Miss Billy. So now there I have my 3 pieces. I have when x is less than or equal to -3. I have when x is between -3 and 0. And I have when x is greater than 0. So let's do the first piece first. Okay? Hey, it's less than or equal to, so let's just put -3 in and figure out what that point is. Let's go f of -3. And I see if I'm at -3, I'm at this piece right here. So I'm going to put -3 into the top piece. So that's going to be -2/3 times -3 plus 3. Well, the 3's cancel here. Negative makes it positive. This is going to be 2 plus 3, which is equal to 5. So I have this point -3, 5. And I ask myself a question. Is it open circle or closed circle? Billy? Billy? Billy was sitting in front of you, Billy. I'm asking the Billy in front of you.
I'm still making the graph.
You're still making the grid? In the name of the Father and of this. Woo! Okay, the original, Billy. Is it open or closed? Closed, because it's less than or equal to. It's unequal to. And now, it is going to have a negative slope. I'm going to find another point. And heck, let's just find, my grid should be bigger, but it isn't. But I'm going to try f of -6. Why did I choose -6? Anybody know? Because it is a multiple of 3, because it factors with that 3 easy. And so now what do I have? Negative is positive. This is going to be 2 plus 3, and that's going to be a plus 3. And 4 plus 3 is 7. I don't know what happened here. So this is -6, 7. So I'm going to have to come up here 5, 6, 7, and it's going to be about right there. And that's a good one because the slope is down 2 over 3. And so here's the top piece of that graph. Okie dokie. Now let's graph the middle piece, shall we? So now I'm going to graph the middle piece, this 1/3 x plus 1. But look what I can do. It's not at 0. Oh, it is. If it's x is equal to 0, it's going to be 1. So I'm going to put a 1 in there. And does that open or closed? It's closed because x is equal to 0. And what does the slope tell me to do? Go up 1 over 1, but I can't go to the right of 0. So I'm going to go down 1 over 3. Oh, and that's going to be an open circle there. And that's the middle piece right there. This is y equals 1/3 x plus 1. This piece here is y is equal to negative 2/3 x plus 3. And there is an open circle here because notice that x is greater than negative 3 and not greater than or equal to negative 3. That's why there's an open circle. And here's another hint. If it's a piecewise function, there cannot be an open circle above an open circle because of the vertical line test for functions. Okay, so I have the top piece graphed. I have the middle piece graphed. All I have left to do is the bottom piece. All right, and the bottom piece again has a positive slope. Let's find a couple points, Lee. All righty, let's find let's get crazy and find f of 2. Where's 2 at? 2 is right here. I'm going to put 2 into that bottom piece. It's going to be 1/2 times 2 minus 3. Oh. That's going to be 1 minus 3 is negative 2. So this is the point. 2, negative 2 right here. Uh-oh. So the point is going to be 2, negative 2. And now I can do what the slope says, which says go up 1/2, down 1 back 2. And that's this piece right here. You tell me, Billy, is that open or closed? It's open because I'm just greater than 0, not greater than or equal to. That's freaky, and the last thing I'm going to do is I'm going to evaluate this function at some points. If I do f of, say I want to find f of 6, what piece am I going to use? The top, the middle, or the bottom? The bottom. I think you guys are getting this. So this is going to be 1/2 times 6 minus 3. Oh, look at that. 3 minus 3 is 0. That's the x-intercept. That's an x-intercept, and this is the point that represents. Okay? Here's what I would like for you to do now.